Hi, welcome back to another video. Today I'm going to be doing division with polynomials and talking about the two main techniques that there are to divide polynomials. I'm going to start off with a fairly simple question here. Just x squared plus 7x plus 12 divided by x plus 3. And just stating that x cannot be equal to negative 3, otherwise this denominator here would be 0 and you can't divide by 0, otherwise you get an undefined term. So starting off, we're going to do the long division method. This is a nice easy introduction. X squared plus 7x plus 12. So you're going to get your numerator underneath and your denominator to the left side like so. And now you're going to look at these two terms, this x and this x squared, and you go, what is x squared divided by x? Alright, and now this is x, and so we're going to chuck the x up here. Erase all this up, clean it up nicely. And now we're going to look at these two and subtract the product of the two. So x squared plus 3x, multiplying them together, negative x squared minus 3x, and we're going to add this to all of this. Alright, so keeping everything in their columns, the x squared turns into a 0 plus 4x plus 12. Alright, I'm just going to erase that 0. It's an unnecessary placeholder. It was just to show what process we're going through. And now we're going to do the exact same thing as we started off with. Look at this term and this term. What's 4x divided by x? Is 4. And multiply this term by this one, sorry, not the whole top term, just the 4, and subtract that, 4x plus 12, negative 4x minus 12, and add this top bit and this together. Negative 4x plus x is 0, negative 12 plus 12 is 0, and so you get a remainder of 0. Therefore, this up here is equivalent to x plus 4, as was our result if we look over here. Alright, so that's our answer. So it's a little bit involved, especially with the longer ones when you're working with a larger polynomial with a higher power, which I'll give an example of now. So erase all these highlights. Now we'll go into a more complicated question and just look at what sort of things we have to be careful of while we're working through. 7x squared plus 2 plus 4 over x minus 3. So again, we're taking this numerator and we're putting it 3x cubed minus 7x squared 2x plus 4, putting it underneath, and then taking this denominator and putting it to our left. Alright? And now we can start going into what we were doing last time. This 3x squared divided by x. This 3x, put it up there, and then multiply the two orange terms together. Minus 3x, 3x squared minus 3x cubed minus 9x squared. Negative 3x cubed plus 9x squared. You've got to make sure you have these brackets that I've got here, because otherwise you might get it confused. Let me just show you. If you didn't have the brackets, it would just look like this, and you might subtract the 9x squared. So make sure you've got the brackets. You expand the brackets, and then you add the two blue terms together. Alright, so you add that. Negative 3x cubed plus 3x cubed is 0. Just put it there for a placeholder again. 9x squared minus 7x squared is 2x squared. And then you just bring the rest of it down. And now erase the 0 again. Now we're going to go for our next one. 2x squared divided by x is 2x. Alright, clean this all up. I'm just going to speed up the rest of it because I've already gone over it for the most part. Multiply the 2x by this bit here, so 2x. Two orange terms you multiply together. Bring it down here, 2x squared minus 6. Trying to keep everything in line. I have 2x squared again. The two negatives make a positive. 4. You get 8x plus 8. And then we have our next term plus 8. You get minus 8x minus 24, and you get a remainder of 20. Oh, sorry, this over here shouldn't be there. This is just plus 4. Something seemed off. There we go. Plus 4, you get your remainder of 28, because these two negatives work together to make a positive once again. So it's going slowly, but you saw there are a couple slip-ups there that I almost had, even going slowly. So you've got to make sure you practice a fair bit and iron out the wrinkles. And as you saw, if you practice a lot, you can usually see if something seems a bit off and just spot it yourself. But the bright side of this is, even if we do have a slip-up, if we practice the other method, synthetic division, we can compare the two. So we're going to take these exact same numbers that we had up here. We're going to work with the left side first, because that was much simpler. So x squared, oh, actually I'll just copy down this equation. Copy, paste, nice and simple. And what we're going to do is look at the coefficients here. So 1, 7, and 12. We're going to make columns and cut it across here. And then we're going to look at this bottom term, grab a different color, x plus 3, and we're going to see how do we make that into 0. Alright, so how do we make x plus 3 into 0? We make x negative 3. So we're going to take the negative 3 of that, negative 3, and just go as so. So we're going to have these blue bits down here. These colors are really going to help just bring the visualization. So you put your coefficients here, the green, as I highlighted above. You're going to take the x value to make it 0 and put it on the side there. And now you're going to add in columns. So 1 plus 0 is 1, and you multiply with this side term, and so it's negative 3 times 1, which is negative 3, and then you put that in the next column over. Add these, 4, multiply here, negative 12, and that's 0. This is no remainder. And this is our x column. This is our x to the 1 column. This is our x to the 0 column. And this is our remainder column. So whatever coefficient you've brought, see this 1 here is the coefficient of x squared. So you drop the power down by 1, so that x to the 2 becomes x to the 1, and that's the column. So now this becomes 1x plus 4x to the 0, and has a remainder of 0, which is simplified down to just x plus 4, which you might recognize from our answer up here, x plus 4. So we got the same answer, meaning it's correct, because we got it for both methods. And now we're going to go on to our other question we had. Just erase the highlights and grab this one as well. Duplicate, bring it all the way down here. Zoom in a little bit. Alright, sweet. Now, same thing again. We're going to grab these coefficients. 3, -7, 2, and 4. 3, -7, 2, 4. Put them out. Put them into their columns. And then grab our x value to make 0, which in this case would be 3. 3. Let me just highlight these coefficients. I'm really trying to bring out the color matches so you can see where I'm putting everything, and then just give ourselves some blue patches here. Right. Now this first column is always just going to be dropping down the number because you've got a 0 there technically, right? So you just drop down the number here, 3, then you go 3 times 3, and you take this number and put it in there, 9. Alright, let me just clean this up and work through it. 3 times 3 is 9, -7 plus 9 is 2, 3 times 2 is 6, 2 plus 6 is 8, 3 times 8 is 24, 4 plus 24 is 28, and this was our x squared, x1, x0, and remainder columns. So 3x squared plus 2x plus 8, remainder 28, and if we look up here, 3x squared plus 2x plus 8, remainder 28. So we get the exact same answer as we got above. So these two methods are really useful. As you saw, the second one's a lot quicker, a lot more basic maths, but if you get quick at long division, it is still pretty similar speed, and being able to do both methods just allows you to cross-check in case you make stupid mistakes, and then you make sure you don't lose out on those marks. So that's how to divide polynomials. If you've got any questions, just let me know. I'll do another video on it, and I'll see you in the next one.